Hello, calculus students and general seekers of truth. In the last video, we've already seen the ratio test as a very brief introduction and some justification for it, and maybe not a formal proof. So in this video, let's take a look at some examples of the ratio test and how it can be applied to us to help us. I'm going to name these series A, B, and C. Okay. And so I am going to take a look at maybe the first one and the third one, and then ask you to do the second one here on your own. Okay. So if we look at the first one, we apply the ratio test, which is taking, this is solving for A now, the limit as n approaches infinity of the n plus 1th term over the nth term, okay, and seeing what that equals to. And we are going to apply the definition of the series here to this limit. So the n plus 1th term basically just means you take n plus 1 and you replace n with it. Okay. So this becomes something quite convoluted. Negative 1 to the n plus 1 times n plus 1 factorial squared divided by 2 times n plus 1 factorial. Okay, so that's the n plus 1 term. This right here is the n plus 1 term. Now we have to divide by the nth term. So this right here, this expression is the nth term, but we're dividing by that, so we got to multiply by the reciprocal. So that's just 2n factorial divided by negative 1 to the nth times n factorial squared. Okay. And now we want to know what's going to happen to this limit as n approaches infinity. And you can see that this is quite convoluted, but there's a lot of canceling and simplification that we can extract out of this. So the first thing here that I have the negative 1s, they do not matter at all because of the absolute value symbol. They cancel each other out here and there, but because of the nice absolute value symbol, we don't care at all about the negative 1s to the n or the n plus 1. Okay. I am going to just do some additional simplifying so that you can see. So n plus 1 factorial squared is really n plus 1 factorial times n plus 1 factorial all over, I'm going to distribute this 2, so we get 2n plus 2 factorial times 2n factorial over here divided by n factorial squared, so that's just n factorial times n factorial. Okay. Now some very nice cancellations will happen for us. Remember the rule to n to factorials, okay? So just a reminder, n plus 1 factorial is nothing more than n plus 1 times n factorial. Okay? So that means that this right here, these terms cancel with this one, and you're left with an n plus 1 up here. Okay. Since, I'm running out of space here, since n plus 1 factorial is just n plus 1 times n factorial. The same goes for this one and this one. So you end up with n plus 1 up here, and this all reduces down to 1. The factorials here, 2n plus 2 factorial, and I'll write it on the side here, 2n plus 2 factorial is nothing more than 2n plus 2 times 2n plus 1 times 2n factorial. Okay. So that will allow us to also cancel out this term, and it will cancel out this term, and all we are left down here is with 2n plus 2 times 2n plus 1. Okay. Whew. So this becomes the limit as n approaches infinity of the absolute value of n plus 1 squared divided by 2n plus 2 times 2n plus 1. The absolute value of all of that. Okay. So now there is a little bit more algebra that has to be done here. The top will give us n squared plus 2n plus 1. The denominator will give us 4n squared. 2n and 4n will give us 6n plus 2. In the long run, you look at the leading terms, and this will approach 1/4. So that means the series will converge. Okay. So you should look back on this a little bit just to make sure, get a little bit of overview here of what exactly happened. Okay. We have this complicated thing. There's lots of factorials going on in here, lots of complications. Then all we did was compare the next term to the current term, and just to see what would happen to it. And there's a lot of simplification here using some rules of factorials. Lots of stuff canceled out, and eventually we end up with 1/4. So by the ratio test, this series will converge, and not only that, it will converge absolutely. All right, I'll end this here and start another video on maybe part C here, and then I'll leave you to work on the second one on your own. Thank you for watching, and have a wonderful day.